let's look at another example. This is example 2. The weights of frozen pizzas produced at the Atlanta facility of Fresh Farm Foods are normally distributed with a mean weight of 28.3 ounces and a standard deviation of 2.7 ounces. What is the probability that a randomly selected frozen pizza at this facility weighs more than 32 ounces? So the first thing is, identify, is this involving a binomial distribution, a normal distribution, or neither? These exercises are good to have because they'll usually mention whether it's normally distributed. This mentions it's normally distributed, and that's a giveaway that this is involving a normal distribution. So to solve this, we're trying to find the probability that x is greater than 32, that the weight is more than 32 ounces. One way to work this out is to use a graphing calculator. On the Casio calculator, if you use that, you would use the function called NCD. On the TI calculators, you would use the function called normal CDF. And when you're working out this kind of a problem, it helps to draw out a normal curve and shade the area that represents that probability. So the mean weight was 28.3 ounces. This is a normal distribution. I'll draw out a normal curve. Remember that on this side of the curve is lower numbers, and on this side it's the larger numbers. So 32 would be somewhere above 28. It's maybe around here. I'll just put it here. So 32. And the probability we're looking for is the probability that the weight would be more than 32 ounces. So anything that's more than 32. And in theory, the curve goes forever towards infinity. So the area of that shaded region, it's equal to the probability that x is more than 32. On the Casio calculator, you would take these steps, get to the function called NCD. When you get to that function, it'll ask you for the lower bound, the upper bound, the standard deviation, and the mean. The lower bound is the left boundary of your shaded region. The left boundary is 32. The upper bound is the right boundary, but there's no right boundary. This shaded region, in theory, goes to infinity. So for your upper bound, instead of putting infinity, you can put just a very large number, let's say 10 to the 99 power. Put in the standard deviation, put in the mean, and execute, and then that will give you the result. On the TI 83 or 84, similar, you want to take these steps, find the function normal CDF, enter the lower bound, 32, the upper bound, infinity, or 10 to the 99 power, the mean and the standard deviation, enter that, that will give you the result. Either way, you should come out with the result of 0.0853. Another way to find this probability is to use a table. And again, if you're using the Sullivan Statistics book, it's called Table 5. It's the standard normal distribution table. If you're using another book, then you probably have a similar table, but it may be called something differently, or it might look a little bit different. But using this table, Table 5, it still helps to draw out a normal curve. And I'm going to start by doing just that. So again, 32 is the lower, or the left boundary. Infinity is the right boundary. The first thing that you want to do if you're doing it this way is to find the z-score. The z-score can be found using this formula. X is the 32, and then you put in the mean and the standard deviation, put them into the z-score formula, and you'll get 1.37. And that just means that 32 is 1.37 standard deviations above the mean. By doing that, we've converted our probability so that it's no longer in terms of x, but now it's in terms of z. These two have the same value, but now that it's in terms of z, we can go to the table and look up that the z-score. The z-score was 1.37. Go to this table, look for a z of 1.37. Here's 1.3, and here's the 7. We'll see where those line up. 1.3, and here's the 7. They line up right here at 0.9147. But you want to keep in mind that that 0.9147, it represents the area to the left of that z value. It's kind of described by this picture that comes with the table. If this z represented the z value of 1.37, what we just found is the area to the left, 0.9147. But remember from the problem that we want to find the area that's to the right of that. And so to get the area to the right, you find the complement, which is 1 minus 0.9147. So find the complement, 1 minus 0.9147, and it comes out to that same result that came from the calculator, 0.0853. One more example, example 3. For your birthday, you received a box of 20 chocolates containing 8 truffles, 5 nut clusters, and 7 creams. You close your eyes and you randomly select 3 chocolates from the box. What is the probability that the first 2 are truffles and the last is a nut cluster? The first thing is, we want to identify, is this involving a binomial distribution, a normal distribution, or neither? So one thing is that there's no mention of normal. And so that means that this is probably not involving a normal distribution. The other thing we'll want to ask is does the variable have only 2 possible outcomes? And the answer is no. Every time you select a chocolate from the box, you could get a truffle or a nut cluster or a cream. That's 3 different outcomes. And so all of that means that this is not a binomial distribution. So the answer, I guess, is that this is neither. And if it's not normal and it's not binomial, then you'll need to use other methods to solve it. And one way of solving all other types of probability problems is to draw pictures and just think about the context of the problem. Think about what's happening. So let's imagine that this is our box of 20 chocolates. Here are the 8 truffles, the 5 nut clusters, and the 7 creams. And we want to find this probability, the probability that the first is a truffle, the second is a truffle, and the third is a nut cluster. This is a sequence of events, and that means that you're going to multiply probabilities. So let's imagine you take the first chocolate. The probability that that first chocolate is a truffle is 8 out of 20. There are 8 truffles to choose from out of the 20 chocolates. So that's 8 out of 20. Now we'll multiply. And let's suppose that we've picked out a truffle from these chocolates. So we've picked out the truffle. We're not going to pick that truffle again. We've already taken it out. Now the chances that we would pick out another truffle will be 7 out of 19. There are only 7 truffles left, and there are 19 chocolates left. So we've selected 2 truffles so far. There are only 18 chocolates left over now. So the chances that the last chocolate is going to be a nut is going to be 5 out of 18. There's 5 nuts left over, and there are 18 chocolates to choose from. So 5 out of 18. Multiply all of those together. We could multiply the denominators and the numerators together. You'll come out with the fraction 280 over 6,840. And when you work that out and divide that, it comes out to about 0.0409. Alright, that will be our last example for our lesson.